The Atacama Large Millimeter Array. The Atacama Large Millimeter Array, which is also referred to as ALMA, is an Earth-based telescope. The ALMA is located in Chile and is a collaboration of many different countries from around the world. This telescope is used to study star formations, molecular clouds, and the universe, and has made many discoveries over the years. Located on the Chajinero Plateau in the Chilean Andes, the ALMA has an elevation of 16,500 feet or 5,000 meters. ALMA has an array of antennas and compact antennas that allow for detailed imaging. It uses interferometry, where two or more antennas pick up a signal from the universe and join forces to analyze the signal and obtain info on its source or emission. ALMA consists of 50 12-meter antennas that are used for precise, high-resolution imaging, 4 extra 12-meter antennas that are used for power, and 12 7-meter antennas that enhance the fidelity of wide-field imaging. The ALMA has a total of 66 telescopes or antennas. Is the ALMA reflecting or refracting? The ALMA is a reflecting telescope. As the radio waves are received from space, they hit the dish and bounce up to the second mirror that is above. The secondary mirror reflects the radio waves down to the main part of the telescope, which is called the front end. The picture on the right shows how the ALMA reflects the signals and communicates them through the technology. The ALMA's range of electromagnetic radiation, or EMR, is quite extensive. Its wavelengths range from 0.3 millimeters to 3.6 millimeters, and down to 10 millimeters, which is quite a wide range. The ALMA's array has configurations that have a maximum baseline that is about 150 meters to 15 kilometers. The ALMA uses its 66 radio telescopes to collect EMR at both the millimeter and submillimeter wavelengths. The ALMA uses interferometry to collect information, which I previously mentioned. The astronomical signals travel from the antenna to the main computer named the correlator, which is pictured on the left. The picture on the right shows how the arrays collect the signals and transport the information to the correlator. Adaptive optics are used in telescopes to be able to see the finer details of smaller astronomical objects that are usually not visible from Earth. Adaptive optics allow astronomers to see the most minuscule details. In addition to its main array, the ALMA also consists of an Atacama compact array that has 4 12-meter antennas and 12 7-meter antennas. The 7-meter antennas focus together on a smaller area and provide a general image of the objects observed. The 12-meter antennas measure separately and can measure the absolute glow of the astronomical objects. Who funded ALMA? ALMA is an international astronomy facility that was funded through a partnership between many different nations. The partnership is between the European Southern Observatory, the U.S. National Science Foundation with the National Research Council of Canada, and the Ministry of Science and Technology in Taiwan, NINS with Academia Sinica in Taiwan, and the Korean Astronomy and Space Science Institute. North America, the ESO, and East Asia shared in the building costs of the facility. Chile provided the observation site. Who uses the data collected from the ALMA? ALMA is operated by the ESO, the National Radio Astronomy Observatory, which is managed by Associated Universities, Inc. for North America, and by the National Astronomical Observatory of Japan for East Asia. The data collected from ALMA is used by astronomers and scientific teams to study objects in the universe, star formations, and molecular clouds. Discoveries. In 2011, the ALMA displayed a new view of the antenna galaxies, which is pictured on your right. In 2014, the ALMA observed the HL and provided the image that revealed planetary genesis. In 2018, ALMA detected the most distant oxygen molecules that were known at the time. Also in 2018, the ALMA, with the use of other telescopes, helped reveal the inner web of the stellar nurseries in the Orion Nebula. In 2019, ALMA was used to observe the swirling clouds, large colorful belts, and giant storms that are characteristics of the storms on Jupiter. In 2020, the AMA observed a unique view of dust and gas in the cosmological deep field. In 2021, astronomers used the AMA to map the nearby universe and reveal the diversity of star-forming galaxies. Left is pictured the distant oxygen molecules that were discovered in 2018, and on the right is pictured the star-forming galaxies that were discovered in 2021. Some additional discoveries made by the AMA include that the AMA has also worked with other telescopes to produce the first image of a black hole, which is pictured on your left, and the AMA studies asteroids, comets, moons, and other planets within the solar system. AMA also helped NASA to accurately locate Pluto, which allowed the NASA mission New Horizons to view the dwarf planet. The photo on the left pictures Jupiter, and the photo on the right is the picture of the dwarf planet Pluto. These are the different websites that are used to gain information and photos of the Atacama Large Millimeter Array. Here is another picture of the arrangement of the AMA. This concludes my presentation on the Atacama Large Millimeter Array. I hope this presentation has helped you learn more about this fascinating telescope.